A warm greetings to one and all. In this session, let's learn about solving the problem using k-means clustering algorithm. The input data points are x1 of 1, comma 1, x2 of 1.5, comma 2, x3 of 4, comma 4, x4 of 5, comma 7, x5 of 3.5, comma 5, x6 of 4.5, comma 5. Now we need to group the above data points into two clusters using k-means clustering algorithm. The distance function uses Euclidean distance. So it is calculated via the formula distance of x minus c. Here x is the data points and c is the cluster centroid, which is equivalent to square root of x1 minus c1 the whole square plus x2 minus c2 the whole square. Now let's choose the cluster centroid randomly. Cluster 1 centroid is x1 of 1, comma 1. Cluster 2 centroid is x4 of 5, comma 7. Here we have data points value, distance formula, and centroid values for our reference in this table as shown. Let's consider the step 1. Here, the distance between the data point x1 and centroid 1 is calculated via C1, and the distance of the data point x1 and centroid 2 is calculated via C2. In C1, we need to find the square root of x1 minus C1 the whole square plus x2 minus C2 the whole square. Now we can substitute the values. The values for x1 is 1 and C1 is 1. Therefore, square root of 1 minus 1 the whole square plus the value for x2 is 1 and the value for C2 is 1. Therefore, again 1 minus 1 the whole square is equal to 0. Now we need to find C2. Here, we need to find the square root of x1 minus c1 the whole square plus x2 minus c2 the whole square with respect to data point x1 and centroid 2 value. So let's substitute the value. Square root of x1, that is 1 minus c1, 5. 1 minus 5 the whole square plus x2, that is 1 minus c2, that is 7. 1 minus 7 the whole square, which is equal to 7.2. Now we can assign the distance value to the centroids from the data point. That is, the distance between the data point x1 to centroid 1 is 0, as we have found here. And the distance between the data point x1 and centroid is 7.2, which we have found here. Now we have to find the minimum distance. The centroid 1 has the minimum distance. So we can assign cluster 1 for the data point x1. Now let's consider the step 2. So now we need to find the distance between the data point x2 and centroid 1 and the distance between the data point x2 and centroid 2 via C1 and C2. The value which we have calculated is 1.1 for centroid 1 and 6.1 for centroid 2. So we can assign the values here. The minimum value is for centroid 1. So the data point x2 is assigned to the cluster 1 here. In next step, we have to consider the data point x3 and we have found the distance to centroid 1 and centroid 2 via C1 and C2. So the value was 4.2 for centroid 1 and 3.2 for centroid 2. So the minimum value is belonging to centroid 2. So the data point x3 is assigned to cluster 2. So next we have found the distance for the data point x4. So the distance between the data point x4 and centroid 1 is 7.2 and the distance between the data point x4 and centroid 2 is 0. So the minimum value goes to centroid 2. So the data point x4 is assigned to cluster 2. So next we have to find the distance for the data point x5. So the distance between the data point x5 to the centroid 1 is 4.7 and the distance between the data point x5 and centroid 2 was 2.5. Since the centroid 2 is having less value, less distance, we can assign the data point 5 to cluster 2. Similarly, we have found the distance between the data point x6 and the centroid 1 as 5.3 and the distance between the data point x6 and centroid 2 is 2.1. So the minimum distance is for centroid 2. So we can assign the data point x6 to cluster 2. Since all the data points have been assigned to the target cluster, now we need to update the cluster centroids. So in first step, to update the cluster centroid, we consider the cluster 1 data points. The cluster 1 data points are x1 and x2. So the value of x1 is 1, 1 and the value of x2 is 1.5, 2. So here let's consider the first point as x and the second point as y. So now we have to add the x points and divided by 2 since we have 2 points here, and we have to add the y points and divided by 2 here since we have 2 points. So therefore 1 plus 1.5 divided by 2 and 1 plus 2 divided by 2, which is equivalent to 1.25 plus 1.5. So this is the new updated centroid value for cluster 1 right now. Similarly, we have to find the cluster 2 data points. The cluster 2 data points are x3, x4, x5 and x6. So the values of x3 is 4, 4. The value of x4 is 5, 7. The value for x5 is 3.5, 5. The value for x6 4.5, 5. So now we need to find the centroid value. So the formula is, so in the same way which we have found the cluster 1 centroid, we have to find here also. That is, we have to add the x values of all the data points divided by total number of points, and we have to add all the y points divided by total number of points. So the formula is 4 plus 5 plus 3.5 plus 4.5 divided by 4, and 4 plus 7 plus 5 plus 5 divided by 4. So the centroid value for cluster 2 is 4.5, 5.2. After calculating the updated centroid values for cluster 1 and cluster 2, now we have to move for the next iteration as we have done earlier. Now we have to consider the same input data points and we are using the same distance formula, whereas we are using the new updated centroid values for centroid 1 and centroid 2. The updated value for centroid 1 is 1.25 and 1.5, and the updated value for cluster 2 is 4.25 and 5.25. Now let's calculate the distance between the data point x1 and centroid 1. The value is 0.6 and the distance between the data point x1 and centroid 2 is 5.4. So the minimum value is 0.6, which is assigned to centroid 1. So the data point x1 is assigned to cluster 1. Next, the distance between the data point x2 and centroid 1 is 0.6 and the distance between the data point x2 and centroid 2 is 4.3. Since the minimum value 0.6 is assigned to centroid 1, the data point x2 is assigned to cluster 1. Next, the distance between the data point x3 and centroid 1 is 3.7. Similarly, the distance between the data point x3 and centroid 2 is 1.3. So here, the minimum value is assigned to centroid 2. So the data point x3 is assigned to cluster 2. Next, the distance between the data point x4 to centroid 1 is 6.7 and the distance between the data point x4 and centroid 2 is 2. So minimum value is for centroid 2. So we assign the data point x4 to cluster 2. Next, the distance between the data point x5 and centroid 1 is 4.2 and the distance between the data point x5 and centroid 2 is 0.8. Since the minimum value is assigned to centroid 2, the data point x5 is assigned to cluster 2. Similarly, the distance between the data point x6 and centroid 1 is calculated as 4.8 and the distance between the data point x6 and centroid 2 is calculated as 0.4. The minimum value is 0.4, which is allocated to centroid 2. Therefore, the data point x6 is assigned to cluster 2. In both the iterations, we can notice that the assignments of data points to the target clusters remain same. Yes, since the assignment did not change after the iterations, the algorithm converges and the clusters remain final. Cluster 1 includes the data point x1 and x2 and cluster 2 includes the data points x3, x4, x5 and x6. Hope you are clear in K-means clustering algorithm with this example problem. Thank you all.